Okay, so Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. Just in case you didn't know, we are almost to the end of the first sem. So this is week 17, so next week is going to be the last week for the first semester. So next week will be the last week, week 18. So this is the second last week orang panggil. Last second week, whatever. Okay, let's see. It's already 4:01. I think at 4:02, I'm gonna start straight away. Just to test first, is the mic okay? Can you guys hear me clear? Sebab hari ni dia macam tukar mic sikit. How is it? Does the sound quite clear for you? Okay, so clear. Clear okay lah. Risau jugalah kalau tak clear kan. Okay, so let us start straight away. So this is the last lecture for chapter 9 and then we're going to finish chapter 9 so that on this coming Tuesday we are going to start with a new chapter, chapter 10. Okay je? Okay, very good. Clear? Wah, super clear Tapi hari ni kalau tiba-tiba terputus tu mungkin line tak okay lah kot. It's raining over here. Oh, hi everyone. Okay, so we are going to learn about parametric differentiation today. So this is basically towards the end of chapter 9. So we have learned the basic rules of differentiation. So we have learned the basic rules and then we have learned how to differentiate for a ln, the trigo function and then the exponent. And then we have learned implicit differentiation. So basically this is the end, which is parametric differentiation. Okay, so basically at the end of the lesson, you should be able to use the parametric differentiation to find the first as well as the second derivative. So we're going to calculate to find out what is dy over dx and d2y over dx square. So those are our two aims. So we want to find dy over dx as well as d2y over dx square. Okay, so the Cartesian equation of a line is a rule which link the x coordinate and the y coordinate of the general point xy on the line. So sometimes it is useful to express y and x as the function of the third variable, say the t. So this is parametric equation. So basically we're going to write down x in terms of t and y in terms of t. So x, let's say x equal to 3t, y equal to 2t, and suddenly we want to know what is the relationship between x and y. So we want to calculate what is dy over dx. Okay, so basically you can easily determine the Cartesian equation by eliminate the t from the parametric equation, but sometimes it can be quite tough to eliminate the t for both of them. So that is the reason why we simply differentiate them and then we're going to use the formula, the chain rule, of course, to find out what is dy over dx. Okay, so if we want to find the first derivative of the parametric differentiation, dy over dx, okay, so let's say we have x in terms of t, so x equal to ft and y is equal to gt. Then by using the chain rule, so dy over dx, this is actually dy over dt times with dt over dx. So that means we're going to differentiate this to get dx over dt. And we're going to differentiate the y to get dy over dt. And then we're going to use the formula. So dy over dt is actually equal to dy over dx is dy over dt multiplied with dt over dx. So since we have dx over dt and dy over dt, so this is similar to having dy over dt and divide them by dx over dt. So you can choose to have dx over dt and then you take the reciprocal for this. Ambil reciprocal tu yang kita pusingkan fraction tu. So we're going to do 1 over to get dt over dx, or what you can do is that you simply take dy over dt and then you simply divide them with dx over dt. So nak guna formula yang ini boleh, yang ini pun boleh. Okay, so now find dy over dx in terms of the parameter t if, okay, so x is equal to 3 over t, y is equal to the square root of 1 plus t squared. For this one, x is equal to negative cos of 3t and y is equal to 2 sine square 3t. Okay, so let us go to the first one. So x is equal to 3 over t. So what do? Normally, I prefer to use the power rule. So I'm going to bring this one up. So this is 3 to the 3t to the power of negative 1. For this one, I'm going to change it to become 1 plus t squared to the power of half. And then for this one, we're going to bring the power down, deduct 1 to the power. For this one, bring the power down, deduct 1 to the power, but then don't forget you should multiply with the derivative of 1 plus t square. Okay, so x is equal to 3t to the power of negative 1. So bring the power down. So we are going to get negative 1 times with 3, t to the power of negative 2. So that is how you end up with negative 3 over t square. So I'm going to bring the t to the power of negative 2 down. So that is how we get negative 3 over t square. Meanwhile, for the y is equal to 1 plus t square to the power of half. So we're going to differentiate them using the special power rule. Okay, so we're going to bring the power down. Okay, so bring the power down. We are going to get half. Copy down the function again. So 1 plus t square. But instead of half, you need to deduct 1 to the power. So when you deduct with 1, you are going to get negative half. And this is what you have when you differentiate 1 plus t square. So differentiating 1 plus t square, we are going to get 2t. And then since you have 2 over here, 2 over there, and then you can easily simplify them. Okay, so what do we have here is dy over dt. So simply take this one and then you times them with dt over dx. So over here, this is negative 3 over t squared. So this is dx over dt. If you want dt over dx, then simply take the reciprocal for this. So that is how you end up with d squared over negative 3. Okay, so now I'm going to cancel out the 2 now. So what do we have is negative times with t square times with t over here. We got a t and t square. So that is how we get negative t cube. And then the 3 over here come in front. And then this is 1 plus t square to the power of negative half. You bring them down. And then since we have something to the power of half, we're going to write them down as a set of 1 plus t square. Okay, so that is basically how we're going to do this. So take the first derivative to make sure to use the chain rule. Applying the chain rule and make sure you simplify them until your dy over dx. For your dy over dx, simplify them. Cakap dah tak betul. Okay, next. Right, so now we got x equal to negative 3 cos 3t and y equal to 2 sine square 3t. Okay, so over here we got a square. So for me, I prefer to rewrite this as 2 sine of 3t square. So for me, I prefer to write them as this so that we can easily use the power rule later on. Okay, so let us differentiate this. So dx over dt, so we're going to differentiate cos. Differentiating cos, it will become negative sine. So we have negative sine of 3t times with negative 1. And then we should differentiate 3t after that. Okay, so negative sine 3t, and then we're going to differentiate 3t, so it will become 3. Okay, so differentiate cos, we get this, and this actually comes from d over dt of 3t. Okay, of course, you can easily simplify them. So negative is positive. Positive times 3 is 3. So we got 3 sine 3t. And then for the second one, dy over dt. Okay, so we're going to bring the power down. So we're going to have 2 multiply with 2 sine of 3t. And then we're going to differentiate sine of 3t. So we're going to get cos of 3t. And then differentiate 3t after that. We are going to get 3. Okay, so just in case you couldn't see what happened, I'm going to write them very slowly over here. So this is dy over dt. Okay, so this one over here, this is 2 sine 3t square. So what do? We bring the power down. So we're going to get 2 times 2. So this is 4. Copy down the function sine of 3t, but instead of 2, we are going to get 1. And then after that, we have to differentiate sine of 3t. Okay, differentiating sine, we are going to get cos. So this one will give us cos of 3t, but then don't forget you have to differentiate 3t. So that is basically how we get 4 sine 3t cos 3t and then times everything with 3. Okay, so now we're going to times all the constants. So multiply all the constant. We are going to get 12 sine 3t cos 3t. And then, of course, you're going to use the chain rule. So dy over dx is dy over dt times with dt over dx. So dy over dt is this one over here. So we're going to get 12 sine 3t cos 3t. And this is dx over dt. So in order to get dt over dx, I have to take the reciprocal for this. So 1 over everything. So it should be 1 over 3 sine 3t. And then we should try to simplify them as simplest as possible. So we got a 12 over here, 3 over here. So you can actually simplify them. And then sine 3t over here, sine 3t over here. So you can also simplify that term. Okay, cancel out. So what do we have left is simply 4. Not 3, 4. 4 kali 3. So this is 4 cos 3t. Okay, so done with this one. So let us proceed with example 2. So in example 2, if x is equal to t over 1 plus t and y is equal to t square over 1 plus t, but t cannot be equal to 1, why do they write down this? Is to make sure that we didn't substitute with incorrect value of t, of course. And then you need to show that dy over dx is t multiplied with t plus 2. Okay, so basically, we have x equal to t over 1 plus t. Therefore, in order to differentiate this to get the x over dt, we need to use something called the quotient rule. So you need to use a quotient rule for this. Meanwhile, y is equal to t square over 1 plus t. Again, you need to use a quotient rule for them in order to get dy over dt. Okay, so now I'll give you a few minutes for you to calculate what is your dx over dt as well as your dy over dt. Let me give you around 5 minutes in order for you to get dy over dt and dx over dt. Once you have done that, you can proceed to dy over dx later on. So I'll give you 5 minutes. So at 4:19, I'm gonna give you my answer. Oh, kecil lah skrin ni. Sekejap saya besarkan jap skrin dia. Barulah besar sikit. Hari ni macam tak ramai je. Hujan kot dekat rumah. Oh, by the way, just in case kalau ada siapa yang rasa macam nak give up dengan differentiation kan. So before this, I don't really like differentiation as well. I mean during my matriculation year, sebab saya pun matriculation juga kan. So during my matriculation year, I don't really like differentiation as well. But after a while, once you get the hang of it, dia rasa macam not bad, macam okay jugalah. Dia awal-awal memang rasa macam penat sikit sebab rasa macam banyak sangat formula kan. Tapi once kita macam dah tahu nak guna apa, nak guna formula apa, once dah ada formula tu, dia macam mudah je lah. Just need to be extra careful. You need to make sure you didn't do any careless mistake. Careless tu kadang-kadang benda yang macam simple je lah. 4 kali 2 pun kadang-kadang kita boleh dapat 6. We don't get 8 sometimes. 4 times 2, we don't get 8. Sometimes we do get 4. Or perhaps you get 6. Or perhaps you get a 2. So those are the careless mistake that we cannot really afford to do. So maksudnya kena banyak-banyakkan practice. Kalau rasa macam sentiasa buat careless mistake tu, I would really advise you to do the question again. So contohnya kali pertama tu nampak careless mistake dekat A. Kali kedua tu nampak careless mistake dekat B. Kali ketiga nampak careless mistake dekat C. Kalau dah banyak-banyak kali, biasanya lah dah 2-3 kali tu kita dah more careful with our calculation. So yang itu biasanya dia macam boleh a good practice for you untuk avoid careless mistake. Sebab bila setiap kali kena tulis banyak kali kan, lama-lama dia rasa annoyed, so dia akan macam pay more attention when you write things down. Okay, so Adira ada. Okay, fine. Right, so now let me show you the working for this. We're gonna use the chain rule. Okay, so dy over dx, so the formula for the chain rule. So we're gonna use vu prime minus uv prime over v square. So we are going to get the v 1 plus t, and then differentiating t, we are going to get 1 minus t. Differentiate 1 plus t, we are going to get 1 over v square, so over 1 plus t square. Okay, and then of course you need to simplify your numerator a little bit. So we got 1 plus t over here. So this is 1 plus t minus t. So simplify them, you are going to get 1 over 1 plus t squared. Right, again, we're going to do the same thing for dy over dt. So dy over dt, we're going to take the v. So v is 1 plus t. Differentiating t squared, we are going to get 2t minus, so the u is t squared, and then we're going to differentiate 1 plus t in order to get 1. So t squared, differentiating this to get 1 over v squared, so 1 plus t squared. So what do we have is, right, so this one, you're gonna get 2t plus 2t squared minus with t squared. So what do you have is t times with 2 plus t over 1 plus t squared. Okay, so now let us use the chain rule for this. So dy over dx, we're going to take the value. Okay, so we got dx over dt and dy over dt now. So the formula for the chain rule is dy over dt times with dt over dx. So this is dx over dt. So we're going to take the reciprocal for this. So dt over dx, you're going to take the reciprocal. So this is 1 plus d square. Okay, so we got 2 t times with 2 plus t. Oh, payahnya t dengan 2 tu sama. T, 2 plus t over 1 plus t square and then times them with 1 plus t square. And then, tada, cancel, cancel. So what do you have is simply t multiplied with 2 plus t, and that is what we want to prove. Done. So let us go to example 3 then. So find the value of dy over dx if x is equal to t minus 1 over t, y is equal to 2t plus 4 over t when t is equal to 2. So the first one, rule of the thumb, jangan ganti nilai siap-siap, nanti habis tak ada benda nak kira. Never, never. Never substitute the value straight away, never. So do make sure to differentiate them first. So differentiate to get dx over dt, and then differentiate this to get dy over dt, and then do make sure to use the chain rule to find out what is dy over dx, and then your dy over dx should be in terms of t, then you substitute with t equal to 2. So jangan ganti awal-awal lah, nanti ganti awal-awal dapat constant, lepas tu kosong 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 macam tu je. Cannot. So do make sure to differentiate each of them and then gonna use the chain rule. Okay, so dx over dt. So over here, I'm going to bring this one up. So this is t minus t to the power of negative 1. So this is x. Y is equal to 2t plus 4t to the power of negative 1. So we're going to use the power rule for this. So this is 1. And then we're going to bring the power down. So negative 1 times with negative. So it will be a plus. So plus 1 over t squared. Okay, so now we're gonna simplify this, or we're gonna change this into a single fraction because it will make our life much more easier. So if you have the x over dt and it looks like something like this, the best tips that I can give you is to make sure you change it into a single fraction. So pastikan tukar dalam bentuk single fraction. That will make the calculation much more easier. And then of course we have dy over dt. So differentiate 2t, we're going to get 2. Differentiate 4t to the power of negative 1. You're going to bring the power down, deduct 1 to the power. So it will become negative 4 over t squared. Again, this is something with a fraction. So do make sure you change it into a single fraction. Oh, we couldn't see the number now. Okay, so what happened is that you are going to get 2t squared minus with 4 over t squared. And then we're going to use the chain rule. So dy over dx is equal to dy over dt multiply with dt over dx. So this is our dy over dt, 2t squared minus 4 over t squared. dt over dx, do make sure from dx over dt, you're going to take the reciprocal. So make sure pusingkan lah. Sebab tu that is the reason why I ask you to use a single fraction. Once you have a single fraction, then you can simply flip them. Kalau single fraction, dia boleh flip tau. Kalau kata dia macam 1 minus 2x kan. Let's say you have 1 minus 2 over x. Then this one, you cannot simply take the reciprocal pusing-pusing macam tu. Cannot. But if you have 1 minus x over 2, this one you can flip them. Yang ini boleh sebab dia single fraction. Tapi kalau dia dalam bentuk yang macam ni, tak boleh lah. Nak flip je. Yang ini boleh. Okay, so now you're going to times them with t squared over t squared plus 1. And then if you do them correctly, there should be something that can be cancelled out. So we're going to cancel out the t squared and t squared. So we are left with 2t squared minus 4 over t squared plus 1. So now we do have dy over dx in terms of t. So this is when you're going to substitute the value of t. So substitute t equal to 2 in. So you're going to get dy over dx is 2 times 2 square minus with 4 over 2 square plus with 1. So this 2 square is 4, 4 times 2. So this is 8. So we got 8 minus 4. Over here, we got 4 plus 1. So it will be 4 over 5 or 0.8. Biasanya kita tinggal dalam fraction je lah. 4 over 5. Okay, next. Second derivative of parametric equation. So this one you need to be extra careful. It's not like having something that we have in implicit. So implicit kita boleh differentiate straight away. But for parametric equation, there's some extra term. Dia ada extra sikit. Okay, so the answer for dy over dx are usually in terms of the parameter t. Therefore, in order to find the second derivative, which is d2y over dx square, we will need to apply the chain rule again because our dy over dx are in terms of t. So it's like dy over dx equal to ft. So you're gonna do d over dx of dy over dx. So this is like having d over dx of f of t. So to differentiate this, when you are having something with different variable, you need to apply the chain rule. Okay, so if x is equal to ft, y is equal to gt, therefore the second derivative will be d over dx of dy over dx, and it will be d over dt of dy over dx. So after that, you need to times them with dt over dx. So this is normally when you forgot. Normally this part, it will be quite okay, you know that you need to differentiate. Tapi yang ini part yang biasanya kita selalu terlupa. But for parametric differentiation, you need to make sure that you have this extra term behind because we're going to apply the chain rule for them. So it will be d over dt, dy over dx times with dt over dx. Okay, so let us go to the example then. Okay, so the parameter t is given by, the terms of parameter t is given by, so x is equal to 2 over 1 minus t square, y is equal to t over 1 minus t. Firstly, you need to show that dy over dx is 1 over 4, 1 minus t, and then you need to find out what is d2y over dx square. Okay, so again, be careful. This is the second derivative of parametric differentiation. So once you differentiate this with respect to t, you still need to times with dt over dx. Right, so now let us calculate what is dx over dt. Okay, so dx over dt, we are going to apply the special power rule for this. So bring the power down. So you're going to have 2 times with negative 2. Copy down the function. So we have 1 minus t. But instead of negative 2 over here, we're going to deduct 1. So that is how we get negative 3. And then differentiate 1 minus t. So you're going to get negative 1. So we got 2. 2 is simply the constant. Bring down the power, negative 2. Copy down the function, 1 minus t. Deduct 1 to the power, negative 3. Differentiating the function, we are going to get negative 1. And then, of course, you're going to simply times this. So you are going to get 4 over 1 minus t cubed. So this is basically for the x over dt. So you can easily use the power rule for them. But for y, we need to be extra careful because we have a fraction over here and then we have a t in our numerator as well as a t in our denominator. Therefore, we're going to use some chain rule for this. Oh, no, not chain rule, quotient rule. The quotient rule for this. Okay, so we're going to use the quotient rule. So this is v u prime minus u v prime. So v u prime minus u v prime over v squared. So v u v. So v is 1 minus t. Differentiating t, we are going to get 1. So that is why there's no 1 over here. And then u is t. Differentiating 1 minus t. So that is how you get negative 1 over v squared. So 1 minus t squared. So now simplify them. So we are going to get 1 minus t plus with t. So it will become 1 over 1 minus t square. So now in order to get the first derivative, we have to apply the chain rule. So dy over dx is dy over dt multiply with dt over dx. So for this one, we already have something in a single fraction. So ini dah bentuk single fraction. So kita boleh flip je lah. Okay, so I'm going to flip that one. So it will become 1 over 1 minus t squared times with 1 minus t cubed over 4. Okay, so now we're going to simplify the power. So this is cube, this is 2. You can actually simplify them. So you're going to get 1 over 4, 1 minus t. Okay, so that is for A. Now we need to calculate for the second one. d2y over dx square. Okay, so now let us differentiate dy over dx with respect to t, and then we're going to times them again with dt over dx. Okay, so we're going to differentiate 1 over 4, 1 minus t with respect to t, and then we're going to times with dt over dx. So this is 1 minus t cubed over 4. Okay, so differentiating this, we're going to differentiate 1 over 4, differentiating 1, 0. Differentiating 1 over 4 times with negative t, therefore it will become negative 1 over 4. So we're going to have negative 1 over 4 times with 1 minus t cubed over 4. Of course, you can easily times the 4 and 4. So we are going to get negative 1 over 16, 1 minus t cubed. And that is actually the simplest one. Okay, so now the last example, I'll give you some time to try them. So if x is equal to t, e to t, and y is equal to e to the power of 2t, find dy over dx and d2y over dx squared at 0.01. So you are supposed to have some value over here. So the x is 0, the y is 1. So you can easily find out what is the value for t. Once you know the value of t, you can easily calculate what is the value for dy over dx. Okay, so I'll give you around perhaps 10 minutes will do, I think. So 10 minutes. So this is until 4:43. So try them first. And then we're going to check our answer later on. Ada yang dah dapat jawapan ke? Kalau ada yang dah dapat jawapan, you can write down your answer and then we're going to check what is your answer later. So you can easily write down A equal to something, B equal to something. After that, we're going to check our answer together. Oh, ada seorang dah dapat jawapan dah. So, Shita dah dapat dah. B dapat Shita. One more minute to go. Oh, B dapat -4. Okay, so other than this answer, anyone else got the answer? So A dy over dx at 0, 1 is 2. Okay. A to B -4. Ramai juga yang dah dapat jawapan Okay, so now let us check the answer then. Okay, let's see. Right, so what do we have here is x equal to t, e to the power of 2t. So of course we're going to use the product rule for them. So one of them will become the u, another one will become the v, and then we're going to differentiate them. Okay, so basically u is equal to t, v is e to the power of 2t. Okay, so u v prime plus vu prime. So u is t, differentiating e to the power of 2t is 2e 2t plus, okay, so this is e to the power of 2t, differentiate t, we are going to get 1. Okay, so now this is actually 2t plus 1 e to the power of 2t. So this is dx over dt, and then you're going to calculate what is dy over dt. Okay, so dy over dt, we simply copy down the exponent, differentiate the power. So we're going to times them by 2, so 2e2t. And then to calculate dy over dx, we should use the chain rule for them. Okay, so dy over dx is 2e2t times with 1 over 2t plus 1 e2t. And then as you can see, you can easily cancel those two. So we got 2 over 2t plus 1. Okay, so basically when x is equal to 0, t is also equal to 0. So we got, before this, we have e to t as the x. Okay, x is equal to e to t. But this term, you know, right? If you have e to the power of something, this one is definitely cannot be equal to 0. So that means if x is equal to 0, then that means t is definitely equal to 0 because the exponent cannot be equal to 0. And in fact, exponent, if you have y equal to 0, that is actually the asymptote, right? Okay, so now when x is equal to 0, t is equal to 0, so substitute. So we got 2 over 2 times with 0 plus with 1. So this is actually equal to 2. So now let us calculate the second derivative and let us substitute with d equal to 0. So for the second derivative, it's supposed to be d over dt, dy over dx, times with dt over dx. So we're going to differentiate what we have before this, our dy over dx. So we're going to differentiate 2 over 2t plus 1, and then we're going to times with 1 over 2t plus 1, e to the power of 2t. Right, so this one, I'm going to use the power rule. So I'm going to bring them up. So this is 2t plus 1 to the power of negative 1. So we are going to differentiate 2t plus 1 to the power of negative 1. Bring the power down, copy down the function, deduct 1 to the power, and then differentiate the function. Okay, so we are going to get negative 2 times with 2t plus 1 to the power of negative 2 times with 2. So once we differentiate 2t plus 1, we are going to get 2. Multiply with 1 over 2t plus 1, e to the power of 2t. And then you're going to bring this one down. So we got negative 4, 2t plus 1 cube, and then e to the power of 2t, substitute with t equal to 0. So you're going to get negative 4 over 2 times 0 plus 1 cube, e to the power of 0. So this one is 0 plus 1, which is 1. 1 cube is simply 1. E to the power of 0, that is also equal to 1. So that means we are going to get negative 4. So that is actually the final answer. Okay, so I think most of you get them correct. So well done everyone. Tahniah, dapat betul. And I think that's the end of this lecture. Okay, so basically let us check the working then. So in order to get the first derivative, so we simply do dy over dt times with dt over dx. So that is the first derivative. For the second derivative, so firstly, we need to differentiate d over dt of dy over dx, d over dx of dy over dx. So you need to use the chain rule over here. So this is d over dt of dy over dx multiply with dt of dx. So nak dapatkan second derivative, this is term yang selalu orang lupa lah sebenarnya. So that's why you need to be extra careful for this one. Okay, so I think I'm done with this lecture. That's it. So end of lecture 1. Lecture 5. So I'll see you guys this coming Tuesday. So we are going to start with a new chapter this coming Tuesday. So with that, thank you. Goodbye. Have a nice day, everyone. Bye-bye.